start by talking about the tangent ratio, but this is going to go straight into both the sine and the cosine ratios as well. So let's just recall Pythagorean's theorem. A squared plus b squared equals c squared. Okay, so it's important that when we're using Pythagorean's theorem or any of like the trig ratios, which we're actually getting into now, that we're dealing with a right triangle. Okay, they apply to right triangles only. So a recap of the hypotenuse. The hypotenuse is the longest side in a right triangle. So that longest side is going to be opposite the largest angle, which is the 90-degree angle. Okay, and the sum of the interior angles is 180 degrees. Okay, so when we talk about the tangent of an angle, we talk about the ratio of the side opposite an angle to the side adjacent. Okay, so our formula is tan theta equals opposite over adjacent. In other words, tan theta, okay, the opposite side is the side that you can draw an arrow through. Okay, you can call that like the arrow method. That's what I call it. And the adjacent, so if you think about the word adjacent in English class, adjacent just means like beside. Okay, so the side that is beside the angle theta is definitely this one. Okay, I just want to point out opposite the right angle is always going to be the hypotenuse. The hypotenuse does not come into play with the tan ratio. So it's just opposite over adjacent. There's two major parts of any ratio, or like the sine, the cosine, or the tangent ratio. So focusing on the tangent ratio, okay, we have the angle, which is right here, or we actually have the ratio. Remember, when we think of ratio, I think of a fraction. Fraction. Okay, so it's the entire right-hand side. So it's either going to be a fraction, or once you sub in numbers and maybe divide it, it may be a decimal, but then again, it may be like a whole number as well. Okay, so let's go ahead and find the tangent ratio for each triangle, and let's express these as a fraction and as a decimal to 4 places. Okay, so we can say tan in this case is going to be x equals, so opposite is again the side that you can draw an arrow through, so 10, and then the side beside x is 4. So the actual ratio portion of this is 10 over 4, but if we divide those, we get 2 over 5. So we can either get 5 over 2 or, 2.5. So this is going to be the ratio part of it. Okay? For B, let's go tan x equals, okay, so remember, opposite the right angle, that's going to be the hypotenuse. Opposite the x is going to be 9. Opposite over adjacent, which is 42. So we either get 9 over 42, which reduces to 3 over 14. So 3 over 14 is the ratio, or 0 decimal, 1, 2, 3, 4. 4 decimals. Okay, and the last one, okay, tan x equals, okay, opposite x, we actually don't know this side, okay, but since we're dealing with a right angle triangle, we can use Pythagorean's theorem. So we can just simply do 13 squared minus 5 squared, and that's going to be our, let's go adjacent squared. So 169 minus 25 is going to be adjacent squared, which is 144. Okay, root both sides. The adjacent side is going to be 12. So our ratio, our tangent ratio, is going to be 12 over 5. Okay, it does not include this hypotenuse, so don't use that. Okay, or when we divide 12 divided by 5, I get 2.4. So that's the tangent ratio as a decimal. So either 12 over 5 or 2.4. Divide divide anything by tan. Okay, so tan doesn't actually mean anything without an angle right next to it. So just think we always see tan theta. In order to reverse the operation tan or the function tan, what we need to do is actually tan inverse and then whatever goes beside it. So we're going to take the tan inverse of both sides. So example 2, let's calculate the measure of each angle to the nearest hundredths. Okay, so that's 2 decimals. Okay, so we have tan A equals 5/6. In order to get rid of this tan, we have to tan inverse. That tan and the tan inverse will cancel each other out. So what we're going to get is A equals tan inverse 5/6. Okay, and you just put that into your calculator, tan inverse 5/6. And just make sure that the 5/6 is in brackets. You should get 39.81 degrees. And that is going to be your angle because what we're doing is solving for the angle. Okay, B, let's tan inverse both sides. The tan and the tan inverse allow each other to cancel out. We have M equals tan inverse and then bracket 22.5 over 36.7. Let's go 22.5 divided by 36.7. Okay, we get angle M equals 31.51 degrees. Okay, and the last one, let's go ahead and tan inverse both sides. Okay, so we have X equals the tan inverse of 1.1918. Okay, and either the fraction with decimals, or the whole number with decimals is allowed. Okay, so I get 50.00 degrees. And I included the 00 in here because this question asks us to round to the nearest hundredth. So we want to include 2 decimals all the time. Okay, so here's a little note. Common error when we do this. When multiplying a number by tan theta, the measure of the adjacent side is always written in front of tan theta. So for example, what we're going to have is we're going to have tan theta equals opposite over adjacent. Okay, when we cross multiply, all this question means is that when we cross multiply this adjacent, put it in front. This is the reason. So we cross multiply the 2, so we have 2 tan 45. Tan of 45 is equivalent to 1, so 2 times 1 is 2. What we're going to see a lot of, which is completely incorrect, is if somebody were to cross multiply it behind tan 45. Because in this way, a lot of students will see, oh, 45 times 2 is 90. And then if you put tan 90 in your calculator, it doesn't work. This is incorrect. Okay, so the tan 45 must be calculated and then the 2. In order to just get into like a good routine, let's just multiply it in front. Okay, so let's do an actual example. Cindy's building a skateboarding ramp and she wants the ramp to rise 1 meter in a horizontal, rise in a horizontal distance of 2 meters. What is the acute angle right here? She should cut the wood rounded to this nearest degree. Okay, so it's like a little wedge skateboarding ramp. So we know that we're going to use tan because we're given the opposite and we're given the adjacent side. Okay, so tan theta equals opposite over adjacent. So tan theta equals 1/2. We want the angle by itself, so we need to tan inverse both sides. We cannot divide by tan. So we have theta equals tan inverse 1/2 or 0.5, it doesn't matter. Tan inverse, I get 26.5, let's go 7 degrees. Okay. Oh, rounded to the nearest degree, let's round up, 27 degrees. Therefore, she needs to cut the wood at an angle of 27 degrees. rounded to the nearest tenth, so 1 decimal. Okay, so we have angle 47. BC is actually the opposite of angle 47, and then 20.46 is the adjacent. So as soon as we know that we're dealing with opposite and adjacent, we can go ahead and sub it in for tan, let's say A, equals opposite over adjacent. Okay, so tan 47 equals, we don't know the opposite, so we can either leave it as opposite, or we can just call it BC, over adjacent, which is 20.46. So here's that rule that I said, just get into the habit. When we cross multiply, because again, one term on the left, equal sign, one term on the right, cross multiply and bring that 20.46 right in front of the tan 47. This way we know that we're not multiplying those two numbers. And for these questions, because when we're doing sine, cos, or tan and we're putting it into our calculators, most of the time we're going to get many, many decimals. So what I do is I just simply leave everything in the calculator. So 20.46 times tan 47 and 1 decimal. Okay, so therefore the length of BC, so BC equals 21.9 meters. Okay, a ladder is leaning against the wall and it reaches 5 meters up the wall. So let's just draw a little picture of that. So here's the wall and then here's the ladder, right? And it reaches 5 meters up the wall. When the foot of the ladder, so when, that's situational, when the foot of the ladder is 6 meters away. So these two only go together. So first, how long is the ladder? Well, let's call this x. How can we solve for x? Well, we know that we're dealing with a right angle triangle because obviously a wall and the floor is going to be at a right angle to one another. So we can just simply do Pythagorean's theorem. Okay, so a squared plus b squared is going to equal that x squared. So 5 squared plus 6 squared, which is 25 plus 36, equals x squared. So 25 plus 36 is 61. Okay, and then if you're more comfortable, you can root it. We get 7.8. Okay, so the length of the actual ladder is 7.8. Now, at what angle is the ladder leaning? So we're trying to find this theta here. Okay, so we can go tan theta equals opposite over adjacent. So tan theta equals 5 over 6. Okay, again, we're not able to divide by tan, so we want a tan inverse both sides. So we get theta equals tan inverse of 5 over 6. And when we punch that into our calculators, we get 39.8 degrees. Let's just round to 40 degrees. And we can say, therefore, the ladder is 7.8 meters long and is leaning at an angle of 40 degrees to the wall. Okay, so when we get a question and asks us to solve, what this means is the question wants us to solve for all three sides and all three angles. Okay, so if we're given this question, example 6, solve the following triangle. So we have two angles here. We have 90 degrees and 40 degrees. So angle P can be easily found by doing 180 minus 90 minus 40. Okay, so 180 minus 90 minus 40, I get 50 degrees. Okay, so right now, all three angles are found already. Okay, and if you want, just to keep track, you can put angle P equals 50 degrees, angle Q equals 90 degrees, angle R equals 40 degrees at the side. We can also do this with the side lengths. We can do this with side lengths PQ, QR, and RP. So PQ, which we know is 4 units, QR, which we know is X units, and then RP, which we know is, we actually don't even know. So we essentially have to solve for QR and RP. That's what's left to solve for. Okay, so let's go ahead and use the tangent ratio. So if we know angle R, we can do tan of R equals opposite over adjacent. So we can do tan of 40 equals opposite is 4, adjacent is x, and we don't know x. So this is a new one. We haven't seen this yet. What we want to do is we still want to cross multiply. Let's bring the x up, but then let's bring the tan 40 down. So these two kind of work on a rope. Like the x can go up or down, the tan 40 can go up or down. Okay, so we're going to just switch the places here. 4 over tan 40. Okay, so let's say x equals 4 divided by tan 40. I get 4.77. Go 4.77. 4.77 units. Okay, and now the last side, PR, all we're going to do is use Pythagorean's theorem. So we're going to go, let's go, this would be side P, the x. We can call it side P, P squared plus R squared equals Q squared. Okay, Q has to be the C value because it's opposite the 90-degree angle. So we have P squared, 4.77 squared plus 4 squared equals Q squared. Okay, 4.77 squared plus 4 squared equals 38.7529 equals Q squared, and then we can go ahead and root both sides. Q equals 6.23. Okay, 6.23 units. So what we've done here is we solved all 3 sides, all 3 angles. We have solved this triangle. Okay, example 7, a radio transmitter is to be supported with a guy wire as shown. Okay, so the transmitter is like, goes vertically, and then the guy wire is just attached to the ground. Okay, the wire is to form a 65-degree angle with the ground and reach 30 meters of the transmitter. The wire can be ordered in whole number length of meters. Okay, so all that means, whole number, is just round to the nearest whole. No, not the nearest hole, the upper hole. Okay, because if you need, for example, if you need 2.1 meters, well, you have to order 3 because you can't get away with just the 2. Like it won't be long enough. So you have to order it longer and then cut it. Okay, so how much wire should be ordered? So let's go ahead and use tan because we know that we're going to have to find how far the guy wire is stationed between the transmitter and the ground, and then we'll have to use Pythagorean's theorem to actually see how long the guy wire is. Okay, so let's call this A, B, and C. We'll just call this side X. Okay, so tan A equals opposite over adjacent. So we're going to have tan A, which is 65, equals 30 over, let's call that X. Okay, again, these two move on a rope. So the X can come up and the tan 65 can come down. So if we put that into our calculators, 30 divided by tan 65, we get 13.98. Let's just round to 14. Okay, so the guy wire is positioned 14 meters from the base. Okay, but that's not what we want to know. We want to know how long the wire is. So let's go ahead and do A squared plus B squared equals C squared. Okay, 30 squared plus 14 squared equals how long the guy wire is. So 30 squared is 900. 14 squared is 196. And if we add those together, we get 1096. Oops. Go over. And then we root it, and we get C equals 33.1 meters. Okay? So therefore, 34 meters must be ordered. Okay, even though usually we would round down the 1 to just 33, we can't get away with 33 because it's not going to be long enough. So we have to purchase 34 and then cut it.